Hello everyone. Welcome back to the AAS YouTube channel. And this is part of the good stuff. This is part of the great stuff. This is the AAS Journal Author Series. And I am delighted to have Sumi Kim with us today. Hello, Sumi.
Hello, Frank. Thanks for having me in here.
Oh, well, thanks for agreeing to talk about your very awesome article, which we'll get to here in a little bit. And Sumi, what is your geolocation? Where are you at?
I'm currently in South Korea, Seoul, University of Seoul.
Very cool. Let's see. And it is October 1 of 2025 as we record this, and the year's going fast. So we're past equinox. And so how is the weather in Seoul? Is it fall or we still got summer hanging out? How's the weather?
Yeah, so in the morning it seems like autumn has already came in through the living room, but in the afternoons, maybe summer hasn't left yet.
Okay, so we're kind of in this transition zone, right? Yeah.
Yeah.
Yeah. So I am in Phoenix and we are definitely cooling down. We are coming out of our summer months and we're heading into our autumn months. But it still hits on the order of, let me do it real quick, 34 odd C or something like that in the mid
Oh.
90 F. So, but it's a dry heat. That's what we tell people. So, but it's very pleasant. We're
Mhm.
definitely out of the brutal heat. So it's very nice. Very good. Let's see. And let me ask, Sumi, what is your position there in South Korea?
Actually, I graduated like last August, but I borrowed this my former office for this discussion.
Oh, very cool. Well, congratulations, Dr. Kim.
Sorry, but actually, it's still miss. But I graduated from the master's degree.
Gotcha. Gotcha. Okay. Well, I'm still going to give you a congratulations, Dr. Kim, when you
Thank you, thank
when you,
you.
when you get there. When you get there.
Okay, okay.
Very cool. Very good. And Sumi, what do you like to do for research?
Well, actually, I would like to say in
Uh-huh.
generally widely, because I did the two kinds of researches. I widely would like to say to studying the structure of our universe through the simulations.
Okay.
So I studied the higher order clustering statistics to estimate the cosmological parameters, and
Yep.
also did the research about the distributions of and features of the satellite galaxies with the simulations in the supernova feedbacks.
Very cool. And that is going to bring us to this very awesome APJ article. It is open access. It's the open access era, people. You can go grab a copy for free. Go get one. Investigating the impact of supernova feedback on satellites and elliptical galaxies. And Sumi, take us away.
Okay, thank you. First of all, I want to thank the all the great co-authors. First of all, Inache, my supervisor, going through all these investigations, and all the other co-authors gave us the important discussion points.
Uh-huh.
Mhm.
Very cool. Good. Good shout out. Good shout out. Okay, let's go ahead and get into it. Intro.
Yeah, so first first of all for the abstract, can you go up for a bit?
Yeah, sure.
Up scroll for a bit
We go to the abstract.
for
Okay,
the abstract?
sure.
Yep. So this research is about the studying the influence of supernova feedback on the satellites
Mhm.
of the elliptical host galaxies
Hmm.
using basically two kinds of simulations. One is fiducial using the mechanical supernova feedback. The
Uh-huh.
second one is already same with the fiducial model, and just varying the supernova outflow velocity and reducing it down in a little bit to make a pseudothermal supernova
Okay, I'm
feedback
good.
model.
Good. I'm with you. Uh-huh.
Thank you. And this kind of two simulations make it two separate two separate results. For example, in the abstract, there is for comparing satellite galaxies above 10 to the 10 to the 8 solar mass, where the weak supernova feedback model generates approximately 5 times more satellites than observed in the extending saga.
Yes.
Mhm.
Good.
And also satellites in the weak supernova feedback model gives about 3.5 times more compact than those observed in the Saga survey,
Okay.
and
Interesting.
gives metallicities nearly 1x higher than in the observed values. So
Okay.
in the conclusion, this research wants to tell not only the AGN is important for the simulation to reproduce the reality, but also the supernova feedbacks are also crucial to replace the not only the elliptical host galaxies, but also their satellite galaxies.
Cool. Very good. All right. I'm with you.
Thank you.
Good. Okay.
So from the introductions,
Whatever you want to cover here is fine.
thank you.
Whatever you don't is fine too.
Thank you. The galaxies are thought to form through mergers, going through a hierarchical formation. And since then, satellite galaxies became a crucial investigation points for studying the massive galaxy formation, including the missing satellite problem, where satellite galaxies around the Milky Way observe found satellite galaxies around the Milky Way were found much lesser than the simulation.
Yes.
And in this missing satellite problem, baryonic physics have decreased the predicted satellite galaxies
Okay.
through the observation values. And since then, the spatial distribution of satellites became the crucial subject for the galaxy studying the galaxy formation physics.
Okay.
But but
Convergence.
all this kind of kind of former studies in the right paragraph
Yep.
primarily focused on the Milky Way analog hosts,
hmm
because the Milky Way and the M31, the Andromeda, were the only large galaxies in the local group where their satellite galaxies are studied well.
Yes.
But recently, the observation results are coming out with much more massive host galaxies.
Yes. Yes.
For example, the result of SDS data release 10 for the result of 2015, and the X-Saga results of the Wu et al. 2022.
Yes. Right. Uh-huh.
Mm.
Yes. Right. Uh-huh. Okay. Good. 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 Good.
And yeah, and despite all, all the and despite these more massive host galaxy study results. Sorry,
All good.
thank you. Despite all these observation study results more massive than the Milky Way,
Yes.
more massive than Milky Way. Only a few studies have analyzed the properties of satellites more massive than host galaxies greater than the Milky Way.
Okay.
And these kind of massive galaxies in the 10 to the 11 to 10 to the 12 solar mass range are believed to have formed through a two-phase process,
Uh-huh.
with especially their outer regions formed with dry minor mergers with the nearby satellite galaxies.
I always love that phrase, but okay.
Therefore, this gives a particular interest and reason to why we're investigating the satellite galaxies
That's a
rather than the host galaxies.
yeah, that's a Good motivation. Okay.
Mhm. So yes, the host galaxies are important, but the satellite galaxies are becoming the building blocks of the massive galaxies. So the investigating the satellite galaxies would give a better insight for studying the formation of the host galaxies.
Yes. Yes. Makes sense. Makes sense. Okay. Cool. Whoops. Okay. Good. So what are we going to do here?
Yeah. So the so the massive galaxies are generally influenced by the agent feedback.
Mm-hmm.
But
Mm-hmm.
what we are studying and focusing is the satellite galaxy. So we are studying the supernova feedback, which gives more eff more effect to the less massive halos, such as satellite galaxies inhabiting halos.
Yeah, absolutely. Okay. Very good.
So what we're gonna do in this work is use the cosmological hydrodynamic simulations, just making the two sets of simulations. One is fiducial and one is weak supernova feedback, and compare the properties of two result satellite galaxies.
Okay. Okay. So we're gonna go mechanical versus thermal. Okay. I'm with you. Mm-hmm. Good.
So what we want to emphasize in this paper is to compare the mechanical supernova feedback effect of mechanical supernova feedback into the satellite galaxies with the comparison of the weak supernova feedback galaxies.
Okay. I'm with you. Mm-hmm.
Yeah. In chapter 2, simulation and methods, I'm gonna briefly go through this chapter with yeah. We use the 11 cosmological zoom-in hydrodynamic simulations. So we have 11 galaxy systems with the 11 elliptical isolated host galaxies
Okay.
with all their satellite galaxies with it.
Okay. I'm with you. Yes.
And the host galaxies stellar mass ranges are within there 10 to the 11 to 2 times 10 to the 11. And these simulations and the simulation
Uh-huh.
employed was is from is from the is from my supervisor in AAS 2017.
Good shout out. Okay.
As I mentioned, there are two sets of simulation fiducial and weak supernova feedback,
Uh-huh.
which just vary which just changes the outflow velocity of supernova feedback. One as 4,500
Okay.
kilometer per second, and weak supernova feedback for the supernova feedback outflow velocity for 10 kilometer per second.
I'm with you. Yes. Mm-hmm. Okay. Good. Good, good. And we have a tool we're going to use here.
Yeah, and we did the and the tool we use here is the SPHGAL, which is a modified version of the Gadget 3.
Uh-huh.
And implemented it in initial conditions from the author's 2010 results and WMAP 3 cosmological parameters in here.
Mm. Okay. Good. Okay.
And I'm gonna go right through the chapter 2.2, the strong versus weak stellar feedback, because this research is focusing the comparing two simulational results
Hmm?
strong and the weak stellar feedback.
Yes.
So in chapter 2.2, strong. Can you go down for
I
a little
will.
bit?
Just absorbing a little bit here. Okay. 2.2, strong versus weak. Mm-hmm.
Yeah.
Indeed, they do. Mm-hmm.
Yeah, so I once mentioned before the effects of supernova feedback are more significant in smaller and fainter galaxies than in larger, brighter ones like the host galaxies.
Yes.
So so the so the studying satellite galaxies are the are better for studying its impact, studying the supernova feedback.
Mm-hmm. Yes, that would make sense. Yes, yes. Uh-huh. Good. Okay.
So this so I once want to note about in here why we just reduce the outflow velocity of supernova sup, outflow velocity of supernova as 10 kilometer per
Huh?
second, not just not just making at the very beginning for the thermal feedback because we wanted to just directly compare the mechanical and thermal supernova feedback models
Right.
under the equivalent conditions.
Right.
So this weak supernova feedback
Right.
model is not a thermal feedback model. It's just a pseudo thermal feedback model. Just
Oh,
want to give a comparison for the mechanical supernova feedback model.
right. It keeps the same model. We don't have to have a completely separate thermal model. Hmm.
Mhm.
Yes. Uh-huh. Yes. And we still keep.
And then there's a mention about the Rockstar which we used as a halo finder, and we used PyGet for checking the galaxy location and calculating the galaxy stellar masses.
Yes. Okay. That's how we're going to find them. Yep. Uh-huh.
Mhm.
Yes. Yes. And then PyGat. Very good. Yes.
Mhm.
Always happy to give shout outs to good software. So there we go.
Yes, they're very good softwares.
Indeed.
So we mainly use recent all 2015 15's observational results for the comparison. They use they u- they use the pro projected distance less than 300 kiloparsec for finding the satellite galaxies, and give a threshold of stellar masses 10 to the 9 solar mass for checking the satellite galaxies.
Okay.
So we did the same for the checking the satellite galaxies.
Cool. I'm with you. Very good.
S-
Ah,
So we
that.
so we made these two kinds of simulations, and the result is very well shown in the figure one,
Let's go to figure one, and here we go.
or maybe the figure two.
We'll
Which
start with
one?
figure one.
Yeah, which one?
Okay.
So the left one is from the fiducial which using the mechanical supernova feedback model, and right one is using the weak supernova feedback model.
Ah, yes. Yes.
And maybe I should have made these circles more visible, but yeah.
They're perfect. I see them perfectly fine. So we have a red
Okay.
one. What does the red one mean?
So the red one means the central host galaxies, most massive ones in the galaxy systems,
Okay.
and the white one is the satellite galaxies, which threshold is higher than 10 to the 9 solar mass,
Hmm.
and in the projected distance of 300 kiloparsec.
Okay.
This is
Okay.
and we already can see in here comparing the left fiducial and the right one's weak supernova feedback model.
Yes.
we we can see we can see the right one's weak supernova feedback model has more satellite galaxies already.
Yes. Absolutely.
Oh, and not circle all the not circled parts,
Yeah.
not circled parts are included and visible in the weak supernova feedback snapshot.
Mm, a lot more dots, let's put it that way. Yeah. Uh,
Yeah. And the size and thank you for highlighting the size of the circles corresponds to 10% of the Vera radius.
yeah. Okay. Good. Good.
And this is consistent one of the example of figure 2,
Yes, and figure two is this.
which has less
Oh, mm-hmm.
has less satellite galaxies than the figure 1 in the video show and also the and also more satellites in the weak supernova feedback model in the than the left ones.
Indeed. A little bit
Yeah.
more so there too. Uh-huh.
So the mention about the number of the satellite galaxies, we can go to figure 3,
Okay.
mentioning for
Good.
the numbers of the
Let's
satellites.
do some histograms. Okay.
Yeah.
Get quantitative. There we go. Okay.
This is so this is, as you can see, this is the histogram showing the stellar mass distribution of all the satellite galaxies in video shell models shown in red and the weak supernova feedback model shown in blue.
Yeah.
So we already can see in here weak supernova feedback has much more satellite galaxies than the video shell ones,
Okay.
especially below the 10 to the 10 solar mass as you can see.
Right. Uh-huh. Uh-huh. Very cool. Very cool. Very good. Okay.
And
I'm with you.
mhm,
Want to do figure four?
yep, yeah, we can go to figure 4 mentioning about the stellar to halo mass relations.
Uh, yes. Okay.
So the so this figure is showing the stellar to halo mass relations with the observational results of Monster 13's observational results and Kravtsov's 18's results for the comparisonal of observational results with our simulations.
Good. Cool.
We can see in here the circular markers is the host galaxies and the star markers are satellite galaxies.
Mm-hmm.
And we can see in here the host galaxies, the differences between the two models are very minimal, not quite pronounced. But while in the satellite galaxies, the satellite distribution of the satellite galaxies are quite model dependent.
Sure. Mm-hmm.
Yeah, showing the masses of satellite. So
Mm-hmm.
showing the solar masses of satellite galaxies of the weak supernova feedback model is way higher than than in the satellite galaxies of video show model in in the similar virial mass ranges.
Yes. Mm-hmm. Good. I'm with you. Mm-hmm.
Thank you.
Okay, good. That all makes sense. Makes sense. Things tied back to the figure one and two. Good. Good, good. Okay. Dotted lines there are one sigmas. Mm-hmm. Cool. Okay. So we will slide down a little bit
Good.
and effective radius.
Yeah, from the next figure, the figure 5 is showing the effective radius as a function of a stellar mass, as you can see. And in here we have the two observational results for the Nipotes 2009 results for the host galaxies and
Huh.
the Sagas results for the satellite galaxies.
Uh-huh. Very good. Okay. Mm-hmm. Mm-hmm.
And we can see in here also the differences between two models in the host galaxies showing host galaxies are minimal there, showing quite similar effective radius.
Yeah.
But in but while in the satellite galaxies,
Very different.
the fiducial the fiducial models are showing way larger effective radius in the fiducial, while
Mm,
the satellite galaxy's weak supernova feedback model is showing way
yeah,
compact effective radius effective radius compact, small, and with much more satellite galaxies than the fiducial ones.
lovely. Perfect. Good. Okay. Hmm.
And this is and this is consistent result with the figure 3 and the
Yes. Hmm. Hmm.
figure 3, 4, and 5 with a
It's all
consistent
hanging together.
result.
It's all hanging together.
Yeah.
Very cool. And then we got some observations here from Saga,
Yeah.
which would suggest a little larger effective radio. Yeah.
Mhm, mhm. Yeah, but yeah, so in here we can see a little bit of negative trend in the fiducial, but we think this is from the low low numbers low number statistics, since we only have 11 elliptical
Ah, right.
host galaxies
Right.
and
Forgot about that.
only 14 satellite galaxies for fiducial simulations.
Yep. Thank you. Hmm.
And the distributions of the fiducial galaxies, the fiducial satellite galaxies, fits well with the observational results of Saga results.
Yep.
So we think fiducial satellite galaxies results fits more with the observational results than the weak supernova feedback results.
Cool. I'm with you. Yep. Okay. So now we got these. I guess we can add them all up and do a cumulative. Let's see. Yes.
Yeah. So this is the accumulated
Cumulative.
number of satellites per the number of satellites per galaxy. It's a quite confu quite confusing y-axis.
I got it. I got it. It's the number of satellites per host greater than some limit.
So what we want to emphasize is here so if we look at the bin of 10, one of tens in quite the middle. So this means this bin is showing
Okay.
the
Okay.
mass of the satellite galaxy is larger than the 10% of the mass of the host galaxies.
Yes. Yes. Yes.
So
Yes.
are you getting?
Okay.
So in here, the
Mhm.
fiducial. So in here, the fiducial satellite galaxy result is only is showing one satellite, and the weak supernova satellite galaxies are showing
Um,
like quite two satellite galaxies showing a quite similar distribution results. But if we see the one to the 100 bin, the leftmost bin.
yes.
So this is the bin of mass of satellite galaxy is larger than the
Considerably.
1.1. So 1% of the 1% of the mass of the host galaxies. We can see in the fiducial model, we can see that there are satellites less than two satellite galaxies.
Hmm.
While in the weak supernova feedback model, we can find more than 8 satellite galaxies,
Yep.
showing much more satellite galaxies. Showing much more satellite galaxies are generated in smaller masses in the weak supernova feedback model. We can find.
Hmm.
And I think I forgot to mention about the observational results, the Ruiz et al., which use the same criterion, in the range of 300 projected kiloparsec, and the above mass of 10 to the 9 solar mass of stellar masses.
Okay.
Mhm. And what we want to know this about in here is although fiducial results are showing about a bit similar results with the S, SA
Yes.
host galaxy results, not the elliptical ones.
Right.
But we can see in the paragraph the result results are quite a lot, quite a lot examples, quite a lot samples. about
Okay.
a bit thousands, but we are only using 11,
Right.
11 simulation results. So this can be low number statistics again.
Could be.
And what we want to
Gonna come
focus
back
is
to that.
what
Yeah.
we want to focus in here is how the weak supernova winds satellite galaxies numbers are much more generated than the observations and the videos.
Yes. I'm with you. Hmm.
Thank you.
Okay, good. Okay, let's see. Figure 5, figure 6. And
And for the figure 7, we can go through.
okay, and close.
In here, the results looks can be look a bit quite controversial, showing weak supernova winds satellite galaxies are weak supernova winds satellite galaxies showing quite similar results comparing with the elliptical host results with RISES 15 observational results, but this is related to the figure 3, 4, and 5 because remember what we showed and I mentioned in
Yes.
weak supernova wind much much more satellite galaxies with smaller masses are generated.
Yes.
So does all the masses of satellite galaxies gather together and make up the satellite galaxies mass for almost comparable for the
Uh-huh. Mm-hmm.
elliptical result for the observation of Ruiz 15's results.
Yes. I'm with you. Mm-hmm.
Thank you.
Yes, and I do remember from those earlier figures. Yes. Okay. Cool. Very cool.
And this and the this kind of number of satellite galaxies comparing with the observations is very well pronounced in the figure 8,
Right.
comparing with the hexagon results.
Yeah.
And I want to note in here
Okay.
from what we note from here is that in only in this figure we set the satellite stellar mass cut to 10 to the 8 and 10 to the 8 solar mass for the comparison with the hexagon results observations
Okay. Okay.
to match with observation results similar with the video satellite galaxies.
Mm-hmm. Doing it lower. Mm-hmm.
And thus we can compare the observations and video satellite galaxy number of galaxies with the weak supernova winds number of satellite galaxies.
Yes.
So if we see the 300 kiloparsec bin in here,
Yes. Womp.
mhm. So for the fitted shell model, we can see a number of satellites in the 300 kiloparsec is a bit like one or two
Yeah.
satellite galaxies.
Mm-hmm.
But if we see the weak supernova winds number of satellite galaxies, we can see it's
Or
over over 12. It is actually 13 satellite galaxies,
yeah. Or
and it is much more way more higher much more way more gen much more generated than the observational results and the visual results.
yes. Mm-hmm.
And it is shown in it, and it not only in the 300 kiloparsec bin and in the overall range, weak supernova wind model is
Oh.
showing excessive number of satellites generated in all these overall ranges.
Uh-huh. Generally overproduced, period. Mm-hmm. Cool. Okay, and just to get these two together, so that's by mass, that's by number. Yes.
Mhm.
Good, good.
And since from now on, we want to check about the star formation history of the satellite galaxies. So in
Fair.
figure 9, maybe.
Yeah, sure. So these are the age distribution. Uh-huh.
Yeah.
Uh-huh.
We check the age distributions of all the stars in the satellite galaxies with the stellar mass over 10 to the 9 solar mass cut. Same with its observational results.
Uh-huh.
All the stars of the satellite galaxies in both models shown in visual in red and weak supernova wind simulation in blue.
Okay. Okay.
So what we want to say in here is if we see the blue lines with the weak supernova feedback model,
Uh-huh.
we can see most stellar masses are formed before 11 gigayear,
Yes.
almost redshift 3.04
Mm-hmm.
They're generate they are generate quite earlier and later
Yes.
generation tendency is decreasing.
Eventually. Yes. Mm-hmm.
And while on the other hand, in the fiducial model, the star formation, in the early times, star formation is quite very suppressed, and most of them are formed in the later times, generating a kind of plateau in here.
Mm-hmm. Yeah. Mm-hmm.
And this is because of the difference of between the two simulations. One is fiducial with the outflow velocity of 4,500 kiloparsec, and other one is with the velocity of 10
Right.
kilometer per second.
Right. So you can definitely see the effect here.
And
Momentum.
the small peak in here in the fiducial one is the starburst of our most massive satellite galaxies in
Okay.
here.
Okay.
So this peak is from the one satellite galaxy starburst.
Yep. Mm-hmm.
That was quite dominant.
Yes. Yes. Okay. Cool.
And from and and for the mentioning about the most dominant satellite galaxies in the figure 10, I want to notice we
Metallicity. Mm-hmm.
that
Yep.
in this figure we're comparing the metallicity between two models, but we excluded the most massive satellite galaxies from each of the model,
Okay.
each galaxy from the model, because they were too dominant and they were quite
Yeah. You know.
affected from the agent feedback. So
Uh-huh. Mm-hmm.
what we want to focus is to seeing the is to see the effect of supernova feedback models. So
Yeah.
we exclude it. So in here, those weak supernova feedback model
Mm-hmm.
is quite super solar metallicity and showing the significant metal enrichment
Mm.
due to the rapid chemical enrichment, which was shown in the figure 9,
Yes.
and also the medium metallicity shown as the downward arrow in
Mm-hmm.
here.
Yeah.
It's also showing quite above the solar metallicity value.
Uh-huh.
While in the fiducial model, there are metallicities, which is super solar metallicity, but there are quite a long and thick tail under solar metallicity, which shows the relatively metal poor distribution due to the late star formation,
Yes. Mm-hmm.
and also the medium metallicity value shows the near solar metallicity.
Okay. Mm-hmm. Yes. Mm-hmm. Okay. Yes. I'm with you.
Uh,
Cool. All makes sense.
mhm.
At least self-consistent anyway. Cool.
So what? So in the weak supernova feedback model, weak, weak supernova feedback model doesn't. This is not. They not the This model not only suppress the star formation, but also not only fail to fail to suppress the star formation, but also to disperse the metals away from the vicinity of the supernova explosions. So they just remain remain close to the satellite galaxies, and it makes the satellite galaxies
Which,
more metal
yep,
more rich in the metals.
that's a great explanation. Good, good. Okay, awesome. Okay, if you
Thank you.
let's
Uh,
see, slide on down, and we've got
and
two more. Mean metallicity.
yeah,
Ooh, this one's more complicated. Okay.
so it's figure 11. It shows the mean stellar metallicity as a function of stellar masses. It's just showing the mean mass mean metallicity of each galaxy. It's just showing one metallicity per one galaxy.
Okay.
So it is consistent with all the former figures, which is
Okay.
showing observational results for the host galaxies with galaxies
It's all good.
2005 observation results and the Panthers oh 08
Yeah.
2008 results.
Yes. It's our
And
black.
already we can see in here, the circle marked host galaxies are showing quite similar metallicity values
Yes.
between between the models, but
Now, Rich. Yes.
but but in the satellite galaxies with these
Okay.
star markers, quite, quite a lot in there, they're showing quite different quite different distribution
Uh-huh.
between the models.
Uh-huh. Fairly flat, less flat, a lot less.
Mhm,
Yes.
mhm.
Yes. What are those? Okay. Uh, do.
So this is yeah.
Okay.
So
Yeah, there's a lot going on this week.
so
Okay.
so as I mentioned, so as I mentioned earlier, this higher metallicity values of the satellite galaxies in weak supernova peak model is
Yes.
due to the early rapid star formation and closely remained supernova
Yes.
remnants the metals. So the remained metals closely remain metals. That is just going back to the gravitational potential of the satellite galaxies and just making it more metal richer, than the fiducial satellite galaxies.
Cool. Yes. Makes
And the fiducial satellite galaxy is this this is distribution this the metallicity distribution of these galaxies are quite similar with the observational results of Pasquale's 10th result. This is for the observational results for the satellite galaxies. This is quite similar
yes.
and quite shows a linear relation. And
Got one there. Okay, I didn't see that.
yeah,
Okay.
and we guess this relation,
Okay.
if
Ooh,
this
got one.
observational relation goes goes to left, and it'll quite match with our simulation results.
Trend is there. Yes.
Mhm.
Mm-hmm. Very cool. Nice figure. Nice figure. A lot going on, but yes, nice figure. Okay, cool.
And next is about the gas fraction. This figure is actually related with the figure 5, the effective radius of the satellite galaxies, because the figure 12, this figure is showing the gas fraction of satellite galaxies to the stellar mass.
Okay.
And all the gas free satellite galaxies are shown as the in the downward arrows in the below.
Uh-huh. Uh-huh. Okay.
So we can see in here. So in here, nine out of 14 satellite galaxy galaxies are having gas, and in the weak supernova feedback model, only 30 out of 95 satellite galaxies are having gas with them.
Still with them, yes.
Mhm.
Mm-hmm.
And also
Okay.
this figure is showing the satellite galaxies of fiducial model are having more gas, generally having more gas Then the satellite galaxies are weak supernova galaxies. So this figure implies with related to the figure five, with related to the figure
Let's take a quick reminder of figure five.
five.
Figure five was effective radius as a function of
Yeah,
this.
making
Uh-huh. Uh-huh. Okay, good. That's
making more of the dry minor
right.
merger evolution with them, and
Okay.
making more compact
Yes.
satellite galaxy results.
Yes. Now let's go down to figure 12 again. Aha. Yes. Okay.
Mhm.
Yeah, that helped to look. Okay. Mm-hmm. Mm-hmm. Very nice.
Yeah, and so the discussion and summary part, the impact of mechanical supernova feedback through supernova driven winds. So comparing the mechanical supernova feedback with the weak feedback effects are summarized as following 4 points. So the first of all, the first one, reduction in satellite galaxy number counts.
Mm-hmm.
The the mechanical supernova feedback significantly reduces the number of satellite galaxies,
Yes.
which has shown in figure 3, 4, 6, and 8. And second, suppression of the early star formations, which was shown in
Yes.
figure 9, and also reducing the total stellar mass,
Uh-huh.
as shown in figure 7.
Yes. Okay.
And
Yes.
also the mechanical supernova feedback makes the delayed chemical evolution,
Yes.
which was shown in figure 10 and 11 for 10 and 11 for the showing the metallicity of satellite galaxies and the stars in them,
Cool.
and also the increased galaxy size for as shown in figure 5, showing the satellite galaxies of video shows are way more larger effective radius
I like
than
that.
the weak supernova ones.
Cool. Very good. Very
Yeah, so this study focuses on the influence of the mechanical supernova feedback on the satellite galaxies.
uh-huh.
And what we want to emphasize in here is including mechanical supernova feedback in simulations are are also the crucial points in investigating galaxy systems,
Yes.
since it is crucial for reproducing not only the host galaxies but also the satellite galaxies as similar as possible with the observations.
Yes. Perfect.
And for the appendix, we gave another test because virtual ones are having quite very fast
Okay.
outflow velocity, about like
Okay. No.
4,500 kilometer per
Uh-huh.
second, and the weak virtual ones were having quite slow 10 kilometer per second. So we made a moderate
Right.
outflow velocity
Somewhere in the middle.
as 500
Mhm.
kilometer per second.
Okay. Usual.
So this is the figure showing the histograms
Hmm.
similar as figure 3.
Yes.
Histogram showing the stellar mass distributions of the satellite galaxies. We can see in here the green histograms, meaning the satellite galaxy results for the supernova outflow velocity is 500 kilometers per second, which is the intermediate velocity. Is already showing the similar distribution with the weak supernova feedback
Yes.
satellite
They're not strong
galaxies.
enough yet.
Yeah,
Okay. Right.
so they're not
Yeah.
to get strong enough to get the enough. This is quite strange term. Not enough not enough for suppressing the
Momentum.
satellite
Yes.
star formation
Hmm.
and making the less satellite galaxies.
Yes. Well, I'll come back to that point. Very good. Very cool. Good. Very nice.
Yes.
Beautiful work.
Yeah, and I think this might be a wrap up for this wrap up for this research.
Lovely paper.
Mm, Thanks
Sumi,
for having me.
thank you so much. Let's see. And you kind of touched on it, or at least you raised some points as we went along. So let me ask, where do you think we go from here, given the published article? Or is there, right? We only had 11 simulations. Is it
Mm-hmm.
worthwhile doing 111 simulations? We did one test there with sort of an intermediate outflow velocity and found it wasn't
Mm-hmm.
quite enough. One might want to do one with 1,000, 2,000 kilometers per second. So basically, is there more simulations to do? Are there additional observations that may be coming down the pipes? And just sort
Mm-hmm.
of next steps. Where do we go from here, given the published article?
Yeah, as you mentioned, there could be more recent observation results to compare.
Hmm.
And there would also could be a room for the branch work because in this research we did the analysis for the 10 to, above the 10 to the 9 solar mass satellite galaxies.
Right. Oh,
But
oh,
we can do a research for the dark galaxies where no stellar particles in there.
okay.
We have quite a lot of
Good.
satellite galaxies in our simulations, so we can search about when these dark satellites are formed, whether whether they whether they were came from the beginning or whether they generated in the middle of the simulation, or they can have a star in the middle of the simulations because in this research we just did analysis of the satellite galaxies in redshift 0 the nowadays.
Uh-huh. Hmm. Right. Oh, yeah. Okay. Right.
So we can do an analysis through the redshift evolution through the simulations,
Cool. Yes. Yes.
and there
Good
there
thing to
could
do.
be a quieter room for the next work.
Cool. Very good. Very good. Well, it'd be really exciting to see those future next steps taken, and probably will make an awesome PhD thesis, I bet.
Thank
Future Dr. Kim. Very cool.
thank
Well,
you.
thank you so much for walking us through your very awesome article, Simi. Very good. And that will do, everyone. And I hope this made your astronomy day just a little bit better. And we will see you on the next one. Bye bye.
Thank you.
Thank you.